Hello friends, today we are going to discuss about the abnormal combustion in CI engines. After learning this topic, one should be able to answer the following questions. First, explain the normal combustion in CI engines. Second, explain the abnormal combustion in CI engines. And third, explain the parameters needed to be controlled in order to prevent knocking in CI engines. So let us start. So now let us first understand what is combustion. Basically, combustion is burning a hydrocarbon fuel in the presence of oxygen from the air, producing carbon dioxide and water, along with liberating some amount of heat, which is supposed to be converted into work. Now, this combustion happens in different stages, and here you can see the name of the different stages: ignition delay, rapid combustion, controlled combustion, and after burning or final combustion. So we have different stages. So let us discuss one by one what these stages are and what is happening in these particular stages. So the first stage is ignition delay, which happens from A to B. So from A to B, what is happening? So basically, this particular ignition delay is being divided into two parts, which first part is what we call as a physical delay. And in physical delay, the fuel which is introduced in the form of droplets is going to atomize, vaporize, mix with air, air fuel mixture is formed, and the mixture is going to reach self-ignition temperature. Now the mixture which reaches the self-ignition temperature is going to start the chemical reactions in the chemical delay period. So the chemical reactions means burning is going to start because of the heat, and the mixture has reached the self-ignition temperature. It slowly starts burning, and the droplets is being converted into a fireball. This is what generally happens in the chemical delay period. So, and this physical delay plus chemical delay is what you call as ignition delay from A to B. In the second stage, we have rapid combustion or uncontrolled combustion stage, which is from B to C. And what is the point B? B is the point where the combustion curve departs from your motoring curve. And what is the C? C is the point for peak pressure. So what is happening here? Whatever droplets was accumulated in the combustion chamber during ignition delay stage is now going to, from B, it is going to auto ignite suddenly. So whatever droplets were there injected in the first stage is now going to suddenly auto ignite, and since they are auto igniting, the pressure is going to become maximum, that is around C. Now the third stage is what we call as controlled combustion stage. So in controlled combustion stage, what is happening? It is from C to D. In this particular stage, we are going to control the rate of fuel injection into the combustion chamber, and therefore we have a very controlled manner of combustion happening inside the combustion chamber. That is, we have a control on this particular stage, and therefore it is called as controlled combustion stage. And finally, the fourth stage, which is after D. So after D, your afterburning stage is going to happen, and during the afterburning stage, whatever fuel which is remaining unburned in the combustion chamber is going to slowly burn whenever it comes in contact with oxygen. So whenever there is availability of oxygen, this fuel is going to burn. And these are the four stages in which your normal combustion is going to happen. That is, first ignition delay, where droplet is going to bring it to the condition where it is going to burn. Second stage, it is auto igniting. The third stage, it is going to have a controlled combustion, and the fourth stage, whatever remaining is going to burn. So this is what you call as a normal combustion in CI engine. Now let us see what is the abnormal combustion, which we call as knocking. So in knocking, basically what is knocking? It is related to the ignition delay period, that is A to B. From here, this is your ignition delay, and this is your second stage. So first stage and second stage. So first stage ignition delay is what you are going to the knocking is related to. Now how it is related? Shorter the delay period, lesser is going to be the knocking, and longer the delay period, higher is going to be knocking. So if the knocking is lesser, that is auto ignition is lesser, then we call it as normal combustion. If the auto ignition is more, then we call it as knocking. So this second stage is where the knocking is going to happen, And how it is going to happen? So you can see over here, this first stage of combustion, that is ignition delay, is happening in a it has two sub periods, that is a physical delay and chemical delay. In physical delay, droplet is being injected, vaporized, then the mixture is formed and it is reaching self-ignition temperature, and here the burning is going to happen. So generally this particular is what we call as ignition delay, and this ignition delay is going to be longer, then more fuel is going to be accumulated in this particular stage, because here preferably every droplet has started burning but it has not completed burning, and at the end of this particular chemical delay it is reaching where it can now self-ignite. This is going to burn completely in as a single droplet. So though the fuel has been injected, it has not burned completely. And what happens at a point, that is when the second stage starts, all the fuel droplets which was there in the combustion chamber, which has been injected in the first stage, is going to auto ignite suddenly, and that is where your knocking is going to happen. So if the amount of fuel accumulated in the cylinder is more, then the explosion will be explosion due to auto ignition is going to be higher, and that is higher the auto ignition, we call it as knocking. If the explosion is lesser, then we call it as a normal combustion. That is anyhow whatever is being accumulated is going to auto ignite in the second stage. If only we call it as knocking only if the explosion created is lesser, then we call it as normal combustion, and if explosion is higher, then we call it as knocking. So what is going to then decide whether the knocking is going to happen? That is the amount of fuel accumulated. If the accumulated amount of fuel is more, then explosion is going to be higher, and if the accumulated amount is lesser, then normal combustion, we will say. So if the knocking has happened, then the suddenly more fuel is going to burn suddenly, and extreme pressure is going to be produced inside the combustion chamber. Huge violent vibrations are going to be there. Huge sound is going to be there, and this is how we have what we call as a knocking combustion. So in short, summarizing, what is knocking combustion? Knocking is whatever fuel accumulated in the first stage of combustion is going to suddenly auto ignite, and this auto ignition, if it is more, then we call it as knocking. So it depends on the first stage. So now let us discuss what all things we can do for controlling the knocking in CI engines. So you can see over here the length of this particular first stage, that is ignition delay, is going to decide the knocking in case of CI engines. So let us discuss what this so the delay period consists of a physical delay and chemical delay, and if your ignition delay is longer, more fuel is going to be accumulated and the auto ignition explosion will be more. So the first parameter is ignition delay, and it has to be shorter. So lesser the ignition delay, and that is going to decrease the knocking in case of. So basically whatever done to decrease the ignition delay is going to decrease the knocking in case of SI engine. So second factor is now self-ignition temperature of the fuel. So if the self-ignition temperature of the fuel, obviously the ignition delay will be longer, and if the ignition delay is going to be longer, more fuel is going to be accumulated, and more fuel is going to be accumulated, then knocking is going to happen. So the self-ignition temperature for the fuel in case of CI engine should be shorter. Why it should be shorter? Because if it is shorter, then less fuel will be accumulated. Then the third is compression ratio. The higher the compression ratio, lesser will be the time required for delay period, because the physical activity, that is molecular activity, the chemical reactions are going to be faster, and the delay period becomes shorter. And the shorter the delay period, lesser will be the fuel accumulated, and knocking is going to be controlled. Now inlet pressure and temperature, both the inlet pressure and temperature should be higher, because if they are higher, the activity will be more inside the combustion chamber during the first stage, and the first stage, that is ignition delay period, will be shorter. So a knocking probability is going to become lesser. Next is higher the speed. The speed should be low. Then cylinder size, less. The cylinder size should be larger over here. Now, the larger the cylinder size, it is better in case of CI engine knocking. And cylinder wall temperature. Higher the cylinder wall temperature, more the activity is going to be there inside the combustion chamber, and therefore your knocking is going to be decreased. So that is these are the different parameters which control the knocking in case of CI engines. Thank you.